Okay, it's noon time for Central Time. I'll get started. Today we are on the lecture 9, the scheme language, and this is the third lecture for the functional programming. We talk about the functional programming for the first lecture, and then we talk about recursive call for functional programming and the tree traversal for the functional programming. Now we talk about the third topic that actually is a different language, different paradigm, functional programming paradigm using scheme language. And scheme language is a version, dialect of the Lisp language. And recently it has a new name. So we'll talk about the scheme language. We'll talk about the Rocket, Dr. Rocket programming environment. And we talk about scheme data, list function, conditional, and other program structure. And we talk about functional programming using scheme. So overview, basically Lisp language was the first language that's used for the artificial intelligence because it's Lisp processing. Okay, it's created by John McCarthy at the MIT. And John McCarthy, if you know, he later became a professor at Stanford University. So from early 1960s, he's working at Stanford as a pioneer in AI. Okay, and at that time, Lisp language is supposed to be the language for the AI. So he created the car and CDAR, okay, function, CAR and CDR functions. And then Scheme language was developed in 1975, but Scheme is supposed to be a dialect of the Lisp language. And it's learned by Planner and Converse languages. Okay, and then Rocket is developed in 1995. So Rocket is a new version of Scheme. New Scheme is a new version of Lisp. Good morning. How are you?
Morning.
Okay. I just get started for this section for the Scheme language.
Okay. Sounds
Okay.
good.
Any questions so far?
Yeah, I remember last week it was got your message. It was actually spring break. That's why I didn't get to attend last week's meet.
No problem. Yeah.
All right, thank you.
We actually, because we are online, so we don't care about a spring break or not. But it's okay for people to take some leave for spring break.
Okay.
Yeah, it's okay. I don't worry. Okay. And
All
actually,
right.
we are recording, so not a problem.
Right. Thank you.
And in fact, my son is right now have a spring break in Spain, so it's okay.
Mm, okay.
Anyway, we talk about scheme and Lisp application. So basically, Lisp, it is when it is created is for list processing, and it's created for AI. Okay, it actually originally is actually already created for functional programming, and functional programming is actually related to lambda calculus, and it's created for AI for initially, okay, for expert system. And then if we look at the Python language, so Python language basically the most important data structure I would say is string and also list using the bracket. Okay. So basically Python language is also processing a lot of list. And you can actually put a function in the first location if you consider a function is an object or a value. So basically, whatever you can do with list, you can all do it with Python as well. So basically, Python, if you look at it carefully, is also a kind of supporting whatever calculation you want to have in Lisp. Okay. So anyway, That's the language's relationship. So functional programming language, we have imperative language such as Fortran, Argo, IDA, and C++. Okay, those different languages. These are based on the non-linear computer model. And then we have another kind of language that's actually functional language that's based on the scheme Lisp, ML, Haskell language. These are based on the mathematical model of the computation and lambda calculus. Okay. So we are talking about using the different programming paradigm to do programming. So there are some textbook you can look at, but at this moment, I think the most important reference would be this one and maybe also the video. Okay, that's what you can do. And let's look at the reference site. So basically, okay, basically you need to come to here for the Rocket. Okay, there's no scheme compiler anymore, so you actually need to download this Rocket. But Rocket is a dialect for scheme, so very close. Okay, the grammar in terms of grammar syntax is almost the same for Rocket, scheme, and Lisp. Okay, probably Rocket and scheme are closer. Okay, not last difference. A little bit different from Lisp. I would say Lisp and scheme maybe 80% the same, but scheme and Rocket maybe 95+% is the same. Okay, so don't worry about using this one. So I do download from here for the interpreter. So I download it and then in my C drive program file, I do have the Rocket. So I have this Dr. Rocket, okay? So double click on it. Let me create a shortcut right here, okay? That's a shortcut. So when it come up, it's a little bit slow. I don't know why, but this interpreter, when it just gets started, it actually take a while to get started. Okay, it's coming up. So this program environment, there are two major areas. This is your editing area. This is your evaluation area. So this one is somewhat like your interpreter. It's like Python's interpreter. Okay. So you write your program right here and then you evaluate right here. Okay. So these are the environment. But first thing is that when you get started, you must write your language in the first line. You must start with this. If you don't have this one, it won't run. Okay. But here you can choose language Rocket or language scheme or language Lisp. Okay. I think you can use different language, but for our party's purpose, I would suggest just to put this one language Rocket right here. Okay. And then you can go, I don't know whether it work or not, but you can go +32, okay? And that's actually file save definition as. Okay, it choose the directory you want to go to. So let me choose my own local directory. So here, let me create a new one. This one, let's call it 30. Okay. I think it's CK. I'm sorry. Let me spell it. Okay, over here, let's write it as sample one. Okay, sample one, the RKT file. And then after you save it, you can basically do run And because I use a +3 2, so actually you get a 5, okay? Let me see if I can change the, let me see, can I change the, okay, I cannot. Let me choose preference. I'm sorry, it's preference. So let me see if I choose a bigger font, okay? I can choose a bigger font so you can see it more clearly. So here, change the preference, you can make the font bigger. So that's the environment we actually encourage you to use. And then you can come here to do programming. So here you write a lot of different lists. And this one is your evaluation. Okay, you evaluate right here. Okay, that's the programming environment that we have. So to learn a language, first you need to know about its data type and its programming structure. Okay. So let's look at the basic programming. So Scheme is an imperative language with a functional core. The functional core is based on lambda calculus. So in this lecture, only the functional core and some simple I/O are presented. Okay, we are intended for the basic tutorial. We are not going to cover the whole detail how this language work. Okay. So in functional programming, parameter play an important role, whatever. Okay, Scheme is an applicative language. Okay, whatever. This one. Okay. Then Scheme is weakly typed. So it's with the dynamic typing. So the data type would be determined at the runtime. Okay. So you don't declare an integer a equals 3. No, you don't declare that. Your data actually would you have the set data, but you actually the type would be determined later. So usually you have the first object that usually is a operator or a function. Okay, and then you have arguments. So this one +3 and then times 4, 5. So times 4, 5, you would evaluate to 4 times 5, you actually got 20. And then you actually evaluate +3, 20, that's a 3 plus 20, you got 23. Okay. So always the function is on the first element. So you will have a syntax of EIKE is expression, I is identifier, K is a constant. So one expression is something you evaluate to have value. Okay. So it can be an expression or an identifier or an expression with operator expression operator, the operator and the elements. Okay. Or you can be a lambda function or can be a define function. Okay. These are different. So define with function to set the value to the identifier. Okay. So these are the basic syntax for the Scheme language. So you may have operator 3, 5. So 3 plus 5. Okay, this one is fact 6. I think this one is factorial of the 6. So you get 6 pen. Okay. And then this one is append one list with another. So this code something means something actually means that don't evaluate it. So it actually this one is the list without going further to evaluate the inside. Okay. So you have the two lists and we call it literals and you will append them together. Okay. So this one is the syntax. So your number literal, you have 1, 2, 3, these are something. And function, you can have a factorial or append. Okay. And literal, you have some this as a list. Okay, this is the basic data that you have. So your array is also a list. Okay, so this is the compound data type. So your data type, you have constants such as true or false, you use a sharp T and sharp F. Okay, you have empty list using this, and you have string. Okay, and then you have some atom and string. Okay, so this is a string, and these are the ID. Okay. So here you have A, B, C. You have 1, 2, 3, 1, 3, A, and these. Okay, well, these are different list, whatever. This can be represented in functional notation. So you can do cons, construct. Okay, cons means construct, building. Okay, so building this X with a this. Okay, so actually, this one, there is an empty list. Okay, and the list constructor comes. Now construct the element from the list. Okay. And this one you construct X and then with the construct Y. Okay. Construct Y will build a list and then you will construct this list with X again. Okay. So some integers are atomic. Okay, atomic means that you are terminal. You don't evaluate, explore to into it anymore. Okay, so you have integer, real, and fractional. And you may have Boolean value. You may have a string. Okay, you may have a single character using sharp and some character. Okay, these are the characters. So these are the basic data type, primitive data type. We call it atomic data. Okay. Okay, it's okay. So then operator, you have plus, minus, and division, absolute value, square root. These are different operator. These are something that you can put at the first location. Okay, and the relational. Okay, and you have equal question mark for arbitrary data. Okay. So here they are equal sign and equal. Okay, these are two different operators. Some of them evaluate the value, some of them evaluate them as a reference. Okay, you have to understand them. And then there are logic, okay, a logic operator. So predicate are something that will return true or false. Okay, so you can check number or check if it is integer or check if it is a pair, check if it is a symbol, okay, whatever. These are different predicates that will return Boolean value. So each function has a function and arguments. Okay, this one I think it's not hard. So right here, you can get started with plus 3 to absolute value of -4, okay, times this. Okay, that's actually this one. Let me actually do this. Okay, this one. So right here, you can go and practice right away. So plus 3, 2, we already have it. Then you can also do ABS -4. Okay, after you do this, you can directly do, wait, how comes that I cannot move it? Okay, you can directly do run and you evaluate both rules, okay, both rules. Okay, and then if you have some comments, you can do semicolon, semicolon. So you can do semicolon, 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 okay, and then you say, this is a comment. So when you evaluate, those will be bypassed. Okay, those will be bypassed. Okay, this part I think good enough. So next one is pair and list. So you can do construct 1 and 2. So these two, you will create something called pair. It actually will, this is not a list. So if you construct a banana string and a split string, it will become a This one is a list, okay, not evaluate list, okay, no evaluation. This is just a literal, but it's a 1.2 that actually is a pair, okay. So let's try this one. So let's do. So you do construct, okay. So construct, you can construct one and an empty list. Okay, let's look at this one. Construct one with an empty list. This one here, let's use a single code. Okay, single code means that you don't evaluate this one anymore. Because if you want to evaluate, you need to have a function over there, but we do not have a function. So this one is construct one with this. You basically, when you construct it, you are going to include the one into it. Okay, so that actually is a constructor. And then if you do construct one and then use 3, okay, that's a single do this. And then this one is wrong. So basically, originally you have 2 and 3, but you construct that 1 to become the first element in the list. Okay, so that's a construct function. Okay, but if you here you don't put a list, you put a number, then that will create a pair. Okay, that will create a pair. So in case that you do construct, okay, 3 and then 4, okay, then it doesn't, this is not a list, so you don't put the number into the list because you don't have a list right there. So you create a pair of 3.4, okay, 3.4, that's a pair. Pair means that a data of 2 entry, okay. So that's a pair. Pair and list are different things, okay. And then you can construct, and then let's see, you can construct something, and then this one create a pair, and you do car, you get the first element out. You do CDR, you will get the remaining part out. So you 1.2, you get a first element, and the remaining part is 2, okay. And then you can do pair question mark of this, you get false, that means it's wrong. Empty is empty list. And then you do construct 1, 2, this one is 1.2 after the construction, and evaluate whether it's a pair, you will return true, okay. You can also make 1, 2, 3 as a list, and you check if it's a pair, it's actually false, okay. So this one just example of testing the data type. So next one, you can define a list. Define is setting the data. So this is list 1, 2, 3, 4, 5 is defined for a list. So this is equal to having list equals 1, 2, 3, 4, 5. Okay, equals this in Python. Okay. And then you do car for a list. Car for a list, you get the first element out. Okay, that's actually you will get this one car would give you 1. Okay. And then C star, you will get the rest of it, and you check if it's a list. It actually is a list, so it's true. It is a pair pair actually. Well, it also returns true. And then you define pair by this construction, and then you actually a pair, you actually get 1. Let me see. I think this one is police. This is car and C star. Okay, it is list, not list. And if it's a pair, actually it's a pair. Okay, so this one just to check the different data type using the predicates. Okay. So there are some function for length. They are equal. So equal, you have an equal, you have equal EQ. Okay. EQ text2 reference equals text2 list. So this one will do it recursively. So these two are different. Single equal sign is for elements, atomic data. EQ for reference. So when you have a reference, say reference usually is something you do define. You have an ID X and define Y. You check if this X and Y are the same or not. That's actually test reference. If you do equal sign, you equal 1, 2. That's testing for 1 and 2. Okay, that's two atomic data testing. And if you do EQ equals Q question mark, that's actually testing two list. That would be evaluated recursively. So these three equals are different. You have to know which one you want to use. Car is get the first element, and star actually getting the rest of the list without the first element. And then you have construct list null, check it if it's null, pair, check it if it's a pair. Okay, this one is like that. And then next one, we go to the variable. So variable, you usually use the define for the variable. Okay. So define x1, x become 1, and you also have a set band. Okay. In the list of language is set q, but now it becomes set band. Okay. So set band, you update this value with this value. So this is initially you define a variable, you say x equals 1. And then after that, you can set the value again. This update of the value. So use x plus 3. So it's 1 plus 3. And you update it. So x become 4. And then this one construct to x to a list. It become a list of 4. This one you define clam as 17. And then if you evaluate clam, it will be 17. Okay, so this one actually you go back to here. So that's actually, let's put here. Let's define clam as 17. Okay, so here you do wrong. So you put the rule into the environment, and then right here you actually do evaluate the clam. Clam is 17. Your environment already have that value. Okay, let's actually define clam. Okay, whatever. So you can also use a LUT. So LUT is binding the variable for the whole evaluation. Okay, this actually setting the value for different expression. These are actually setting the variable for the calculations. Okay, the LUT to create a reference environment. So LUT and define are different. LUT is a local variables. Define usually is a function, global variables function. Okay. So log x be 3, y be plus s1. So actually this is s equals 3, y equals s plus 1. That would be equal 4. And then plus xy, you actually do 3 plus 4, you get 7. Okay. So these two are bindings. So here you have a LUT with star. This one LUT with a star. Here you have LUT with star. So there's one problem with LUT is that while binding are being created, expression cannot refer to the binding that have been made previously. For example, it doesn't work. Okay. So this one your X is a known outside the body. Okay. to get this, you actually will provide that star, and then your X can be referenced by the outside. Okay. Anyway, this lot and that star you have to start with. Okay. It actually have difference. Next one is a function. Function, you can have a lambda. Lambda is a lambda function. It's an anonymous function. Function without name. Okay. So we have lambda x1, x2. Okay. It actually is the function doing this. It's called lambda function. And you can also define a function using a lambda expression. Okay. So this is a function, whatever. So you can define double x. Double x is a function that is actually a double function with a parameter of x defined as times 2x. This one create a function. Okay. So let's do this one. Let's actually do, I'm sorry. So this square x is a function f square of x. Okay, this one define a function square of x. And then you need to have the evaluation body. So this is the evaluation body it has. So you do times x, okay? That's your evaluation body, and then you make such definition. Okay, and here you can do square 3, you get 9. Okay, so any questions so far?
No, all good.
No? Are you okay?
Yeah.
Okay, so we actually define functions. Okay, this part, okay. Equality check, okay, equality. So equality, as we mentioned, it had the equal Q question mark, EQB, okay, there's another one now, okay. So there are 3 primitives for equality and identity check, okay. So this one is testing the pointer testing, so it actually testing for a reference, okay, whatever. So this one EQB like this, but that the right sequence compare EQB return true if its argument are equal, or if its argument are numbers that have same value, whatever. So this one is equal value, okay, equal value. It's equal and checking the pointer. And this equals recursive evaluation to the list structure, whatever. So now let's actually have the clam equal 1, 2, 3 list. So clam is a list of 1, 2, 3. And you define aptus as clam. So aptus also referring to the same list. So you do equal clam, it is true. The clam and clam to same pointer, clam to the same thing. Clam and aptus is pointing to the same thing, yes. Clam and quote 1, 2, 3, these are two different objects. It's the same value but different object. It actually has another 1, 2, 3. They are not the same object. They are two different reference. So this one you get false. This one you get false. Okay. And then you compare, if you compare the 1, 2, 3 with 1, 2, 3, it's still false. These two different objects. Right here, the quote 1 to 3 is a list, anonymous list, a list without name. Okay, so they are considered to be the two different lists. So do you do 10, 10 equal? Yes, they are equal. 10.0, 10.0, they are actually not equal. But this one, generally speaking, it has to be implementation dependent. It depends on the interpreter. Sometimes this one is equal. Okay. And equal V value actually is the same value. That's true. So equal V, that's actually is also true. So right here, you see, this one is equal. So they compare the equal of the two pointer. So this one make that false because they may be different reference, but sometimes it's true, okay, depending on the reference, the implementation, program interpreter. But equal V, checking equal value, so these two will be the same, okay. But 10.0 and 10 equal value is a false because it's integer compared to floating point number. That's actually different, okay. And then you have equals for evaluation. This and this you evaluate into it is the same. Okay, so this is equal of the list. Okay, anyway. Single equal sign providing comparison for two numbers, but you cannot use it for the list comparison. Okay. So there are detail you have to really understand the equals, EQ for reference, equals value checking for the object, and equals for the list. Okay, it's different one. You have to really understand the difference. Next one is a logic operator. You have and or. Okay, whatever. I think this is easy. So we don't go into there. Okay. Okay, conditional, we have if and then some condition, you return true part or you return the false part. Okay, this is if statement. So if right here you have the condition and the true and false part, okay, this is if statement. And then you have a define, you have the function, parameter list, and then your value. Okay, so these are if. So we have homework or the quiz, you need to use this, okay, to write the maximum. And then you have a conditional statement. Conditional statement, you actually checking several different conditions. Okay. And then if you pass the first test, you will return this. Pass the second test, you will return this. So this one is somewhat a little bit like nested if. Okay, nested if. So f greater than 80, you do this. F greater than 60, you do this. F less than 35, you do this. Okay. This is conditional statement. Okay, I think this is basic program structure. And then there are cheat sheet regarding the basic functions of the scheme language. So this cheat sheet give you the basic idea of what you can do. So there are read, evaluate, print loop. Okay. So this one you define 10, and then there's a double function. You use the lambda function as the double function. Okay. So you do code hello, code 1, 2, 3. Okay. So code means that don't evaluate the list, but create a list for no evaluation. Okay. These two code for no evaluation. And then you call one this, you get a problem. It's not a function. Okay, this one is like that. And then This one you have lambda definition plus 10. Plus 10 is putting this to define as a plus 10 function. Plus 10 for 3, you actually get 13. Okay, this one conditional, you check in foo and bar's value. If it's equal, you return hello. And then actually, if 10 equals 20, you return goodbye, but you don't, it's not equals, and you don't do this one. This one you say if it's actually foo equals bar, you return hello, you don't return this one. And last one, you stay sharp. P means that you always return error, sorry. So this one is somewhat like a default condition. Okay, default value, like switch statements are default. Okay, whatever. So there are some built-in function that you can use as well. So the built-in function like a plus minus, those are built-in functions. So built-in arithmetic and relational. And then the EQ equals define whatever is built-in. Null is to test a list is null or not, okay? Whatever. So next one is iteration versus recursion. So right here, you need to write everything in recursion for this language, okay? So you don't learn how to write a for loop. Here you need to write recursive function, okay? And higher order function is that you can pass a function into a function. That's called higher order function, okay? And then you have something like a map. Map is similar to the map function in Python's mapping, okay? These are function. And then you can work on the functional programming on the Scheme language, okay? So this one, you define a function, lambda calculus, that's accepting the parameters x, and you return x plus 3. This is a lambda function. And this lambda function, you can apply 3 to it. So it's f of the 3. Okay, whatever. So this is a lambda function with x as a parameter, return x squared. Okay, it's lambda calculus. Okay, these are lambda calculus. So there is a eval. Eval would evaluate y and then using the environment. Okay. So define y as 1, and then you can eval this. When you do eval this is not allowed in the defined area. You can do it in here, but not in here, okay? It's called unbounded identifier, right? So you define these different values, and then you do eval right here. Actually, that's fine, okay? So you can see that eval actually is a function for interpreter, not a language, okay? This is what you need to understand. So this one, you actually eval plus 1, 2, and ns. So this one, you define a namespace called namespace. So you put that into the namespace, Okay. I mean, whatever. So this one, you apply this function to this. So this is a little bit like the so-called aggregation. Okay. In Python, we have the map, a filter, and the reduce function. So basically, this one is the reduce function. Okay. Apply is saying apply right here, but actually similar to Python's reduce function. So you apply plus sign to this, it becomes 1 plus 2 plus 3. Okay. You apply factorial to 3, you get a 6. Okay. So this apply is a higher order function, just like your functional programming in Python, you have the map, reduce, and filter. So this is the reduce function. In here, we call it apply. Okay. So different language may have different name. Okay, so more of the scheme features. So I think this one in general similar to any of the functional programming. It said that you just do it in scheme language. Okay. Here is not supported. Actually, this one become apply. Okay. So you can map check in on a number to each one, and then you create a list. It's a map function. Okay, functional programming map function. Filter, same thing. Okay. And then reduce, you use reduce, you define reduce, but that's not what you want to do. You actually use apply to it. Okay. Each word. Okay, the recursion. This is basic tail recursion. How you define tail recursive function? In general, the same as any function, functional programming. Okay. When you do recursion, it's the same. Okay, right here we have an example of such a state diagram. And you can define the state diagram with this. Okay. This one is the textbook figure 10.2. If you look at it from the programming language pragmatics, okay, the textbook, you will find this one. And then in the language, we actually define the simulation. Okay, it's final. Okay, and then move. And then we put this simulation, put in the data there. These are the example from the textbook. I wrote it in Scheme and run it, and you will get the right result. Okay. Okay. So basically, we go over the chapter 7 to introduce you the Scheme language, and hopefully this will help for your homework. Okay. And then this is just an example of using the functional programming paradigm. And we put this over here, just let you know that functional programming sometimes is using a different language. But in fact, most of people nowadays are using Python or R language to do functional programming for the AI purpose. Okay. If you are doing for the prototyping, usually you are using Python. If you are using the so-called acceleration, you may use a C++ or some other language. Okay. And right here, we just give you the introduce of a different language for scheme language. Okay. Any questions so far?
I'm good. Thank you.
Okay, no question. That's it for today. Okay, see you next time. Bye bye.
Bye bye.